Buddy. Just thought I'd give you a brief rundown on how you can do a manual transmogrification of a plain old Java object into an RMI capable object. Essentially, the subsection of this talk is called Wrapping Existing Java Classes, and the primary goal is to enable the interfaces needed for a remote invocation on a plain old Java object using a unicast remote object. And what you're going to end up doing every time you make an invocation is try to catch a remote exception that can occur during the TCP/IP communication protocol session. So you could have timeouts, you could have unreachable nodes, you could have improper assignments of the registry. All kinds of problems can occur. So let's start with a plain old Java object, a POJO. Here's a hello world object, which simply gets a message, and the message is hello world, and you can even have a little test in here which prints it. The interface involves the remote hello interface, which extends remote. It has to have get message and test get message, both methods which are present in the POJO. And then you're going to implement the interface by subclassing the unicast remote object. This will enable you to invoke this remotely. The hello world instance, the POJO, has a compositional or has a relationship with the unicast remote object. And so what it does is method forward to the local object on the remote host. So then when someone calls get message, it has to throw a remote exception. When they call test get message, it has to do the similar thing. And in any case, it reuses the implementation in the hello world POJO. So then the server has to have a start method, and in order to start the server, what you're going to end up doing is making a new instance of the remote hello implementation, binding that instance to the registry using a remote hello string, which will be known to the client, and then it will just sit there waiting for invocations using a TCP/IP port 1099. That's the common RMI port. So you'll need to know the name of the remote hello implementation instance. You'll need to know the location of the registry, and if it's on the remote machine, you'll need to know the IP address of the remote machine or the name of the remote machine to gain access to that registry. Now comes the client. Now the client comes in. It only makes reference to the interface, not the implementation. It looks up the delegate, which is going to be through the registry. So that's the RH instance, which is the remote hello interface instance. So after a lookup on the delegate has occurred, you'll be able to do the remote invocations. So looking up the delegate, that's the tricky bit. Now you've got to go and do the naming.lookup, which means naming has to have access to the registry. And that means you need to have some mechanism to gain access to the remote client, the remote server. And so you make a new instance of the remote client, which uses the remote server, RMI : localhost remote hello, and then you invoke remotely. So that's hard. You have to start the RMI registry. This opens up the RMI registry in its own window. You can use RMIC to create the stubs, although this can sometimes be done automatically with the IDE. Then you got to run your server. You start the server, you bind the remote instances, and then you wait for invocations. This is a big multi-step process to do remote method invocation, and finally, you get to run your client. And if you didn't do the prior steps in the proper order, this will not work. So that's hard, right? It's like, whoa, that's a lot. So you had to author several classes, a client, a server, and an interface, all to properly wrapper a plain old Java object. Then you had to get your registry running, and you had to make sure things were rebound properly. So that RMI registry, that's a whole other sort of little program that's running that does lookup services. And if you forget to run the RMI registry, you will throw exceptions. And if I have to remember to run something, then you can be sure I will forget eventually or occasionally. And if I run it from the wrong attach point, it won't be able to find the instances that it needs to load. It can't find the bytecodes, can't find class files. It's got the wrong class path. That's a problem too. So now you've got configuration issues. So it'd be really good if we could automate the RMI registry invocation. So what we'll do here is we'll create a singleton pattern because we only want one instance of the RMI registry to run on any single computer, and then we'll bind to the local registry at runtime. So here comes the RMI registry utils in net.rmi.utils. And what that does is it calls restart. If the registry is running, it'll start the registry. Otherwise, when you call get registry, he calls restart, checks to see if the registry is running, and if it's running, it leaves it alone. Otherwise, it gets restarted, and then it returns the instance of the registry. So registry becomes a thing that you gain access to through the RMI registry utils. It becomes the wrapper for the registry instance, and this enables us to do some kind of automation. So we have to have a standard registry port. The standard one for us is 1099. That's the common port. And when you're sitting on a machine at a specific IP address, you need a specific port that's going to accept connections from TCP/IP. So when somebody wants to call start server with the remote hello implementation, I don't need to go to naming.rebind anymore. Instead, I go to the RMI registry utils and get the registry. If it's not running, it starts it. Then I rebind in the registry, and then I say, I'm waiting for invocations. And so now the registry is always started for us, just in case it has already been started. It won't restart it. And so automation is kind of important. It enables us to have consistency, makes distributed computing just a little easier. I know it's not supposed to be easy, but maybe we could just make it a little easier. And then we can start the registry from inside the program, and that's one less thing I have to remember. So RMIC, that's the remote method invocation compiler. That's going to create the implementation stubs. It needs to have a proper destination, or else people won't be able to find the stubs. So that has to be in the class path. And so when you go to generate your stubs, and this is typically done by the IDE, although you can do it by hand, you have to make sure your class path is set properly. And so I have a compilation option within IntelliJ. And the IntelliJ IDE says, look, if you just check enable RMI stub generation, it does it for you, which is really a helpful thing. It also has a mechanism for doing CORBA, the Common Object Resource Broker Administrator, by generating the Internet Interorb Protocol stubs, which allow mixed language invocations. So if Java needs to invoke Fortran subroutines, for example, on some other machine, it can do that. So generating your RMIC programmatically, that might be helpful if you don't have an IDE. And here's a code with a little bit of a bug. You can try and work this out. See if we can gain access to a larger version of it. So here's the RMI tester. It sets a class path, and then what it does is it calls RMIC with args. Whoops. And it calls sun.rmi.rmic.main.main. So RMIC apparently is something that's built into the private Sun libraries, and we can invoke it ourselves. And if we can set up our own little class path, we can invoke RMIC ourselves. So that's kind of an interesting exercise. There are other ways we can automate, and we'll discuss that in another time. One thing I was thinking is maybe we should have a little lecture on semi-automatic static proxy delegation, which would enable automatic wrappering of classes using RMI. And that will be up next. Thanks very much for your time. See you in the next part. Bye.